So, everyone, today I welcome you to this class in which we will discuss about some numerical problems on equilibrium from engineering mechanics. So, this is the first problem which you can see. So, in this problem, what is the problem statement? The unstretched length of spring AB is 2 meter. If the block is held in the equilibrium position shown, determine the mass of the block D. So you can see a spring system is there. Okay, three springs are there. One is AC, another is AB, and the third one is AD. In between these three springs, length of spring AB is given. It is 2 meter. And we can see that at the end of AD spring a mass is there. Okay, so this is a block which is hanging, so it will have some mass, and obviously due to mass it will also have some weight, and we know weight means a force which is acting downward. Okay, and in this direction downward it is acting. Now from the equilibrium condition we need to find out the mass of block D. In each of the spring you can see KAC, KAB, KAD, this information are given. This K is nothing but the stiffness of the spring, and we know that F, the force applied in the spring, is equal to K into X. Okay, so this F is the applied force on a spring, K is the stiffness which is given in the problem, and X is the extension. Okay, so in the springs the tensile force is not given, but tensile force we can find out, this F we can find out from the information. So first thing we need to know K, and next we need to know X, which is the extended length. Now K for individual springs are already given. How to find out this X? Now this can be find out from geometrical information. Now already length of spring AB, the actual length AB is 2 meter, it is given. Now it is in this current position, it is extended. So in the extended position, can we find out what is the length of AB? So hope you can see that this is a triangle, okay, which I am locating. This is a triangle, okay, AB, and suppose this point is O. Okay, suppose this point is O. So AOB is a triangle, and this O angle is 90 degree. So from trigonometry, can you tell what is the length of AB? Obviously you can tell, you can apply Pythagoras theorem. Okay, so also we know Pythagorean triples. If one side is 3 and other side is 4, hypotenuse must be equal to 5. Okay, if you have forgotten this school level mathematics, so you can go to Google anytime, and you can type Pythagorean triples, in the Google and from any website which is based on maths, you can get information about Pythagorean triples. This is a easy trick how to find out values of hypotenuse if you know the values of height and base. And otherwise, if you don't want to avoid the shortcut trick, so you can directly find it out by the uh, formula that C is equal to root over of a square plus b square. Okay, so root over of 3 square plus 4 square. So you will get 9 plus 16, that is equals to root over of 25, so that is 5. So the extended length of the string from the geometry we can tell it is 5. Now what is the amount of extension, that is x. So amount of extension is 5 minus 2, that is 3 meter. Okay, now if you have extension, if you have stiffness, can you calculate the force here? Obviously you can calculate. So this is the way how you can progress. So let us see. Okay, so in this way if you calculate, okay, so what is the value of x? Extended length is 5, original length is 2, so it is 3. Now 3 into, what is the value of k? 30 degree. So 30 degree into 3 is equal to 90. So this is nothing but a tensile force 90 degree at this direction. So we have written 90 Newton here. Okay. Similarly, the other side. Okay. In this side, we don't have any information about the actual length of spring. So let us write by T an unknown tensile force. Also we need to find out the direction. So how to find out the direction? This is 3 meter and this is also 3 meter. So from the basic rule of trigonometry we can tell that angle is 45 degree. Okay, tan inverse 3 by 3 or tan inverse 1, that is 45 degree. So this is also calculated. And number 3, weight, this is already known. Okay, so from this information, now can we calculate, can we find out the mass m? Obviously we can find out, we can apply Lami's theorem. Okay, so Lami's theorem, what is Lami's theorem? I think you have already studied, but let us once again see it. Okay, that will not be a very bad idea. So if three forces, okay, suppose this is P, this is Q, and the third one is R. Okay, so and suppose this angle is alpha. Okay, this angle is beta, and suppose this angle is gamma. So for equilibrium, P by sine alpha is equal to Q by sine beta is equal to R by sine gamma. We all know this equation. So all the three springs are in equilibrium. So in this condition, the Lami's theorem is applicable. So we can put Lami's theorem here. So this was the earliest calculation. So you can put Lami's theorem. So from Lami's theorem you can find it out. Okay, but if you want to avoid Lami's theorem, in that case you can solve it by summation of fx equals to 0 and summation of fy equals to 0. So if you write summation of fx equals to 0, then in the x direction, how many forces are there? One component from T, that is t cos 45 degree. So t cos 45 degree, and in the other end 90 divided by cos of this angle. Okay, now cos means it is base by hypotenuse. So base is 4 already known, hypotenuse is 4 already known. So cannot we write 4 by 5? Okay, so you can directly put 4 by 5. Just think, if you try to find out the angle, then after finding out the angle you need to again calculate what is the cos value for that angle. Instead of that, you directly put cos theta is equal to 4 by 5. Okay, so there is a less requirement of calculation. So 90 into 4 by 5, and you can cancel 5 and 90. So at the end of calculation, this is a very simple calculation, simple algebra. We can find out the value of t. So t is 101.82 degree. Okay, in the other way, you can also write like t by, you find out the angle, you find out this angle. Okay, sine of that. Okay, I'm not going deep into that. I'm just instructing you the method. And w by, you find out this angle. Okay, and that is equal to 90 by, and how much is this angle? 90 plus 45 degree, so 135 degree. So sine 135 you write. Okay, so if you solve this equation, then also you can find out the values of w and t. So just follow this method which we were already discussing. So after we have the value of t, okay, right now you go to solve equation in the vertical direction. Okay, that is summation of Fy is 0. So that means in the vertical direction, how many forces we have? We have 3 forces. One is W. Okay, so this is the negative direction, so write minus W. And other, in the positive direction, we have T sine 45 degree. So T, value of T is already known right now. So write that value and sine 45 degree plus 90 into sine of this angle. Now sine means height by hypotenuse, so 3 by 5 from the triangle we can tell. So this is 90 into 3 by 5. So again, by this simple algebraic calculation you can get the value, and that is W equals to 126 Newton. Okay, so what you have to find out? You need to find out the mass of the block. Okay, so weight, once weight is known, we know weight is equal to mg. So if you divide this value with g, that means 9.81 acceleration due to gravity, then you will get the mass. So you divide it by 9.81, you will get 12.8 kg. This is the mass, and this is the required answer. So we will go to the next problem. So in this problem, you can see the motor at B winds up the cord attached to the 64-pound crate with a constant speed. Determine the force in cord CD. Okay, so in this cord CD, we need to find out the force. Okay, this is the cord CD. So here you need to find out the force. Supporting the pulley at the angle theta for equilibrium. Also you need to find out this angle. Okay, for equilibrium, force in CD and angle theta. Neglect the size of the pulley at C. So at C point we have a pulley. So obviously this is a circle, so this will have some diameter. Okay, but you need to avoid this diameter for the geometrical calculation. Okay. So this is also an equilibrium problem. Okay, how we can know this is an equilibrium problem? Because it is winding up. Okay, the motor is winding up the cord, okay, which is having some load at the other end at constant speed. So we know that constant speed means zero acceleration. That means no force. Okay, no net force is there. That means that is an equilibrium case. So let us find out that how we can let us see how we can find. So we need to draw the free body diagram first. This is the direction of this force. Okay, let us mark it by C, FC. Okay, this is the compressive force working in this direction. Okay, so sorry, this is the tensile force working in this direction, and we don't know the angle theta. And in the other side we have two forces, one here, right here at the downward direction, vertically down. Okay, so negative y direction, that is 65 pound, that is known to us. And the other force which is acting in the direction of CB, that is how much? Now that is also 65 pound. How? Because this is a continuous string. Okay, as this is a continuous string, so within a string, two different value of tension cannot exist. Okay, if tension is 65 pound right here, then it will be same here also. Okay, so that is why this is 65 pound. And also what is given for the geometrical information, 5, 12 and 13, this information is given. So you need to find out the, basically you are asking to this is asking to find out this angle theta. Okay, so here this is the y direction, so this angle theta we need to suppose this is not theta because theta is already given, so this is alpha. So this alpha you need to find out. So how to calculate? So once you have free body diagram, then you can write equilibrium equation in the x direction. So in the x direction, how many forces are there? This force 65 pound is completely vertical force. So it will have zero value component in the x direction, because cos into 90 degree, that is 0. What about the other two forces? One is Fc cos theta and another is 65. If this is theta alpha, this is sin alpha, 65 sin alpha. Okay, so now what is the value of sin alpha? From this triangle we can say sin alpha is height divided by hypotenuse. So 5 by 13. So write FCD cos theta. Okay, let us write this is FCD. Okay, so FCD cos alpha in this direction, and in this direction 65 sin alpha means 5 by 13. So you can calculate from this, and you can find out the okay, you cannot find out right now because there are two unknown. One is FCD, another is cos theta. So then write the y direction equation. So in the y direction we have in the positive side FCD sin theta. In the negative side we have 65 and 65 cos theta. Cos theta means 12 by 13. So 65 into 12 by 13. So you can find out FCD sin theta from here, and you can find out FCD cos theta from here. Suppose this is equation number 1 and this is equation number 2. So if you divide equation number 1 by equation number 2, what you will have, this FCD will be cancelled to unity. Okay, so sin theta by cos theta will be remaining. So tan theta, it will have some value. Okay, so if you calculate, you can get what value it will be. So this is 13 and this is 65. So 5 you will have. Here also you will get 5. So 5 into 12, 60. So this will have 65 plus 60 in the other side. So that means 125, and this will give 5 into 5, 25. So 125 divided by 25 means 5. Okay, so tan theta will be equal to 5, or theta will be equal to tan inverse 5. Okay, you can find out the angle with help of calculator, 78.7 degree. So that is one answer, the value of theta. And other answer FCD, right now when you have the value of theta, okay, so you can find out the value of cos theta also. You can put cos 78.7 degree. Okay, then from this equation you can find out value of FCD also. In this way you can try this in your own exercise copy. So you will get 127 pound. That is the answer. Let us see next problem. A scale is constructed with a 4 feet long cord. Okay, so A to B to C to D. This is a long cord. Okay, and the length of this cord is 4 already given. And 10-pound block D. Okay, so this is a block which is having a mass of 10 pound. The cord is fixed to a pin at A. So one end of the cord, this is one end of the cord, A end. Okay, so this is fixed, and at the other end, okay, so B in the intermediate and in C, these are passing through small pulleys B and C. What do you mean by small pulley here? Just like our previous problem, we need to ignore the dimension size of the pulley. Okay, so you need to ignore the diameters. Determine the weight of the suspended block E. This is suspended block E. If the system is in equilibrium when S is equal to 1.5 feet. This length CD is equal to F. Hope you understand what is the function of this scale. This is basically a weight measuring scale, and this weight, okay, this block, E block, okay, let us write E here, it will be easy for you to understand. So this E block, this is the unknown, and you need to find out weight of this E block simply measuring this length CD, that is also denoted by small s. This is the system. Okay, now if you apply laws of equilibrium into this diagram, for the equilibrium, for a particular value of weight at E, there will be a particular value of this S. Okay, if this is variable, this will also vary, and only reading this length we need to find out what is the weight. That calculation we have to do. What will be the calculation? Let us see. So first we need to find out the angle right here. Okay. So from A to C, what is the length? Total length is 4, and already CD is 1.5. So this is 3.5. Now A, B, C. Okay. So I think you can guess, okay, from this geometry, and always it will be AB should be equal to BC. Okay, AB should be equal to BC. So that means BC is how much? 2.5. 4 minus 1.5 is 2.5 divided by 2, that is 1.25 feet. Okay, that calculation is written here. And the upper side, suppose this point is O, so OC is how much? 1 divided by 2, so that means 0.5 feet. Okay, so now if this angle is theta, so theta means how much? Sin theta means what? Sin theta means 0.5 divided by 1.25. So theta is equal to sine inverse of that. Okay, and the value is 23 point some value 58. Okay, some value or near about 24 degree it will come. Now once you have this angle, you can put it in the free body diagram. Okay, you need to draw the free body diagram at point B. So two forces are there. Okay, now this is a 10 pound. So if this is 10 pound, tension here is also 10 pound. Here is also 10 pound. Here is also 10 pound. Okay, same concept we apply. On a single string, two different tension value cannot exist. Okay, so it is 10 pound everywhere. So two 10 pound forces you show in this direction, and third is weight of this unknown force, WE, weight of E. These two angle we already know. Okay, right now check equilibrium in the x direction. Just we are checking because in the x direction nothing is unknown. 10 pound into sine 23.58 degree. That is equal to, here in this direction also 10 pound into sine 23.5. In positive direction, in negative direction, both values are same. So obviously it will be in the equilibrium. Satisfied this equation. Now move to y direction. So in y direction, in the positive direction, how many forces are there? 2. 10 pound into cos 23.58 degree plus the same value. Okay, 10 pound into cos 23.58. So 2 into that, and in the negative direction we have WE. So from this we can calculate the value of WE, and that is, for this data, this is 18.3 pound. Okay, so weight is 18.3 pound. So this is the solution of the problem. Now dear students, can you see that magic of this arrangement? You are not using any standard mass in the conventional balance for measuring the weight, and not you are using any spring balance to measure weight, but you are using a simple pulley system on which one known mass is hanging. Now in this system, if you apply a mass, unknown mass, simply measuring this height CD, you can find out the value of unknown weight, and from unknown weight you can find out the value of unknown mass. Okay, so hope if you are interested you can try this in your home also. Okay, this experiment is not very difficult. Let us see the next problem. A 30 kg pipe is supported at A by a system of 5 cords. Okay, so 5 cords are there: AB, BC, BD, AE, and this fourth one, this fifth one. Determine the force in each cord for equilibrium. Some information are given. This angle is 60 degree given. Okay, and here 3, 4, 5. This triangle is given. So from triangle you need to calculate the angle. So this type of problem we call connected body problem. What does it mean? It means you need to draw more than one free body diagram, and from one free body diagram some unknown force you will solve. That unknown force will be present in the next free body diagram. Okay, after solving that in the previous free body diagram which is known to you right now. Okay, in this manner you can carry on. Okay, so this is the case of this kind of problem which we call connected body problem. So here you can see, first at point A, this pipe is 30 kg pipe. So can you find out the weight? Obviously we can find out. Weight is how much? 30 into 9.81. So this is in the negative direction. Okay, so write it here, 30 into 9.81. What else we have? In this direction we have a tensile force. Obviously if a cord is there, tensile force will be acting there, so write TAE. And in this direction also we have a tensile force, that is TAB. And this angle is 60 degrees. So for equilibrium in the x direction, what you can write? Sorry, for equilibrium in the y direction, TAB into sine 60, that is equal to 30 into 9.8. One is at the positive direction, other is at the negative direction. So sin 60 value is known. This is also known. Only TAB is unknown. So cannot we calculate the value of TAB? This is a simple algebra. So you can calculate the value of TAB, that is equal to 340 Newton. So TAB is known. Next, solve for the x direction. So in x direction we have TAB cos 60 degree and other side we have TAE. So TAE is a positive, so write positive. Okay. TAE, the other side minus we have TAB, that value is known. Okay. TAB value is calculated into cos 60. So TAE means 339.83 into cos 60. This is 170 Newton. That is also calculated. Now move to the next free body diagram. For free body diagram of point B. So at point B, how many forces we have? This side tension BC, in this side tension BD, and in this side tension AB. Now look, tension AB, TAB is common for both the free body diagrams. Okay, that is why this is connected body problem. So this value already we have calculated. So while we are going for point B, already we have one known value. This thing you need to see, you need to check when you start a problem. At point A, you had only one known. Okay, so start from that point. That time there was no known forces at point B. All the three forces were unknown. Now, once when you solve for point A, then you have all the three forces known, and in between these three forces, one force is common for point B, that is TAB. Now, when you are going to point B, that time there is one known force. So you can solve for other two unknown forces. Let us see how we solve. So we will draw free body diagram first. This angle is 60 degree, that is also known. Okay, from this geometry we can tell that this is also 60 degree. This angle is 60 degree. Okay, and there 3, 4, 5 this information is given. So this angle we need to calculate. So for the y direction, how many forces we have? Whether there will be any component from TBC? No. Okay. Now from TBD, so it will be TBD into sine. Suppose this angle is alpha. TBD into sine alpha. Sine alpha means 3 by 5. So TBD into 3 by 5, right? And in the negative direction, 339.83 into sine 60 degree. So you can calculate, you can solve this equation and you can get the value of TBD. It will be 490.5 or approximately 490. So summation of Fx, that is in the x direction, how much? So summation of Fx in x direction, how many forces are there? One force in the positive direction is TBD into cos alpha. Cos alpha means 4 by 5. So you have calculated the value of TBD into cos alpha, you write, plus 339.83 into cos 60 degree. In the negative side we have TBC. So from that you can calculate TBC, that is 562 Newton. Okay. So I think once you visualize which type of problem this is, then you find out that from which point you need to start. Okay, from which point you can solve. Okay, so for solving this kind of concurrent problems, if you have three forces, one known forces is required. So find out at which point you are getting one known force, solve that. After solving the unknown forces at that point, you move to the next point where you will get some already calculated value for the analysis. So let us move to the next problem. So a figure is given. The boat is to be pulled onto the shore using two ropes. Okay, so two ropes you can see. Okay, this boat is to be pulled using these two ropes. If the resultant force is to be 80 pounds, okay, the required resultant force is given, that is 80 pounds. Directed along the kneel AA. Okay, along the kneel A, the force is required as shown. Determine the magnitudes of the force T and P acting in each rope and the angle theta. This angle theta also you need to find of P is a minimum. T acts at 30 degree from the kneel as shown. Okay, so at the beginning in this problem you need to find out what is the minimum value of theta. Okay, for P is minimum. What is the value of theta when P is minimum? So how to solve that? So for solving this, you need to look at this diagram. So these three forces, okay, P, T, and this is 80 pounds, that is resultant. So if 80 is resultant of P and T, according to the triangle law of vector addition, this should constitute a triangle like this. Okay, this is P, this is T, and in the opposite direction, okay, this was moving in the clockwise direction and this is in the opposite counterclockwise direction. Opposite direction, the resultant should be present. Okay, from triangle law we know very well. Now this is already given and the direction of T is already known. Okay, this is 30 degree. So if this is 30 degree, this is also 30 degree. Angle between 80 Newton and T. Now you need to find out what is the minimum value of what is the value of theta for minimum value of P. Okay, now suppose P is not right here. Okay, suppose this can be sorry. Okay, suppose the line can be present here or line can be present here. Okay, so for any particular position, either you move this angle, you tilt this side in this direction or in this direction, okay, you can vary the length of P, but length of P will be minimum only when this is perpendicular over T. Okay, understand this. Okay, this logic is very much important here. The length of P, okay, you can adjust it. The triangle can be adjusted. Okay, this direction is rigid, you cannot change. This value you cannot change. Okay, both value and direction of 80 pound vector you cannot change. Direction of T you cannot change, but you don't know what is the value of T. That means the length, that is variable. And for P, both direction and magnitude, that means length, both are variable. Both you can adjust. But in order to make it minimum, the only possible way is if you do it perpendicular over T. Okay, then value of P will be minimum. Okay, I think you will agree. You can slide it to any other position, and you can see that if you slide it to any other position, then the value of P will not be minimum. P is minimum only when it is perpendicular over T. That means what? If this is 90 degree, so total sum of all the angles inside a triangle is how much? 180 degree. So theta plus 30 degree means 90 degree. So theta plus 30 is equal to 90 degree we can write. That means theta is equal to 60 degree. So this is the angle for P is minimum. Now once you have this value, then you can apply triangle law. Okay, so triangle law, after applying triangle law, so P by sine 30 degree is equal to 80 by sine 90 degree. Okay, so in this equation only P is unknown, so you can calculate P, that is 40 pound. Next, T divided by sine theta, theta already we calculated sine 60 degree, is equal to 80 divided by sine this angle 90 degree. Okay, so here also only T is unknown, so you can find out the value of T, that is 69. Okay, so you have calculated all the values. So today we have solved first, at the very beginning we have solved this problem with spring, in which main fundamental thing was this law F equals to kx. Okay, and once you have calculated the values of F, you can put this into the equilibrium form. And we know that for planar forces, planar and concurrent forces, we have two equilibrium equations, summation of Fx equals to 0, summation of Fy equals to 0. After solving these two equations, we have got the unknown values. In the second problem, we have dealt with a motor was winding up a coil, a cord, in order to move up a weight. Okay, a 65 pound crate was there. So from the geometry, after drawing the free body diagram, for equilibrium we have solved this problem. Then we had gone through a scale to measure unknown force. We have constructed a scale in which this length, which we denote by variable s, which is to be measured, and this is unknown. Okay, so simply measuring this height s, we can tell what is the value of unknown force WE. Okay, we can measure the weight in this manner. In the fourth problem, we have seen a connected body problem in which only one force was known. Other 1, 2, 3, 4 forces are unknown. But for a particular point, when we have started with point A, we have solved this force and this force. After that, we have solved for B. Then this force is known, AB is known. Then we have calculated BC and BD. And number 5, which was very interesting. So we had started with simple geometrical consideration. Okay. For the minimum value of P, this should be perpendicular over T. That was our consideration, and from that we had calculated the value of theta. Then we have applied laws of triangle, okay, sine law, simple sine law, and we had calculated the value. So that is all for today's class. You can freely ask your doubts to me. So thanks for today. We'll meet you in the next class.